Hi, my name is Hannah. I am a PhD candidate at UC Riverside, and today I will be presenting my work on investigating the fluvial transport of tire rubber particles through a field study here in the LA River. So going into the study, our main motivation, we know that rivers are the primary transport pathway to take terrestrial microplastics and transport them into the ocean and other receiving water bodies. And a lot of the monitoring work up until now has focused on surface water sampling. However, we do have a lot of modeling, like theoretical work, experimental work that suggests that these particles are not necessarily always well mixed throughout the water column. Tire rubber particles specifically are rather dense for microplastic particles, so we suspect that these would be not evenly distributed throughout the water column. So to do this, we went out in the field and sampled in the LA River just to see sort of how the concentrations change as a function of depth, and then how the particle size distributions also change. So this is the LA River here. It's a channelized urban stream. It is, concrete lined. It has very steady flows during the low flow season. And these sort of, reduced vertical mixing can lead to, potential like amplifications of this stratification across the water column. So this is here. We sampled at 5 different depths from the surface down to capturing the bed load. We took a paired sampling approach. So we took net samples to target the coarser fraction. So these were using a handheld bedload sampler, 100 micron net, and then we captured around 2 to 3.5 cubic meters of water. And then we also just took whole water samples using an isokinetic sampler to target this smaller fraction, going down to even like 1 to 20 microns. And then we also measured the velocity at all the depths to construct like a velocity depth profile as well to compare with the concentrations. So a quick walkthrough of our sample processing. Like I said, the 2 different types of samples, we size class all of them. The net samples had a lot more organic matter, so they went through a digestion. Those were then manually picked out. You can see some images of them down here. For the fines, we filtered the 20 to 100 and then above 100 micron samples just directly as they were onto glass fiber filters. And then this sub 20 micron, we actually centrifuged the filters down so that we could combine multiple liters of water onto a single filter without it clogging over time. And then everything went to be confirmed via PyGCMS, so pyrolysis GCMS. And this was me just 1 week ago in Virginia, so hot off the press. We were able to run the whole filters to get a mass per filter. And then these larger particles were just like confirm, deny if what we picked out was tire particles. So now this is adapted from Calgar et al. 2021. The different, just illustrating the different types of loads that particles can be carried as. So basically just where in the water column you'd expect to find them. So given these different categorizations, this is what we came up with given our particle settling velocity. So we would expect these coarse particles to be not as evenly distributed as the fine particles. So our preliminary results, we did find not as strong of a relationship, but we did find an increased concentration as you move down in the water column, and a little bit of an uptick in concentration at the top as well. And we did find a bulk of the ultra coarse particles in this lower half of the water column. Also, the data that I got for the filters for the ultrafines, I just got in like 3 days ago, so I did not have time to put it on my poster. But really interestingly, we actually saw kind of the reverse. So we're seeing it more act as surface load. So we're thinking what's happening is these really fine particles are dry depositing out from the atmosphere onto the water surface. And despite them being heavy, they are very hydrophobic. So they're probably just not breaking through that surface tension. So that was pretty interesting. Overall, the implications of this, given that the concentrations and particle size distributions vary as a function of depth, this has implications on models that have been built just using the data that we have from surface water monitoring. So next steps, we're going to do also a characterization of the suspended sediment throughout the water column as well, and see how that stacks up with our tire rubber particle findings.